Okay, on the CFU, it once again asks us about f, but it's giving us f prime. So it wants to know the min, the max, and the inflection points of the original graph, but all we have is the graph of f prime. So we can't just look at the min and max here to determine that, because we know that f prime and f are going to look a little bit different. So one thing that's going to help me throughout this exercise, again, is to look here. All right, once again, if the original is increasing, that tells me the derivative is positive, right? The slope is going up, and et cetera, right? So this is our relationship between our derivative graphs and our original graphs. So let's look to see how we can identify the minimum of f from this graph. So the minimum of f, let's see. If f has a minimum, we have to have a derivative of 0, and it has to go from negative to positive, right? From decreasing to increasing. So we're going to look for where our derivative is on the x-axis, right? That'll give me a 0. And it goes from below to above, negative to positive. So we got to look x-axis below to above. So let's see. We have x-axis here, and here, and here. But where? So those are all going to be derivatives of 0. But where does it go from below to above? Well, this goes from above to below, positive slope to negative slope. Negative slope stays negative slope, and here it goes from negative slope to positive slope. So this is the only one that has both a derivative of 0, and it goes from negative to positive. So this is going to be just one minimum at x equals, I believe that's 7 in this case. 1, 2, 3. Yep. All right. And the maximum is going to be very similarly found. The maximum is also going to have a derivative of 0, right? Horizontal tangent. But it's going to be on the x-axis and above to below, right? Positive to negative slopes. Say increasing and decreasing, positive slope to negative slope, and a derivative on 0. So that's going to have a max at x equals -2. All right, and once again, that's because of those defining characteristics of f prime that tell me about f. And then lastly, our points of inflection. Our points of inflection are going to look like two things. So we need to know, let's see, the derivative of the derivative, right? Think about that as being like our f double prime, right? The derivative of the derivative equals 0. So how would I find that? That's going to be horizontal tangents of my f prime graph. So if I actually want to find my inflection points, remember that a decreasing graph tells me concave down. Increasing graph is concave up. So any time where that increasing or decreasing changes to create a maximum or minimum, that's going to be an inflection point. This one is not actually a min because it goes down, levels off, and then goes down. It doesn't go back up. So our only inflection points are going to be here, here, and here, where the graph goes from increasing or decreasing, or concave up to concave down, or reverse. So we're going to have -2, 2, and 7. So once again, unlocking these problems really comes from here, because we have f prime, but we need to know about f. That cheat sheet will help you.